So one of the topics we're covering in this course is memoization or caching, writing down values that we've already computed so that we can be lazy and not have to recompute them later. We've used this as one implementation of parsing, but in the real world it might come up in many other places. Brendan, have you had a chance to use it at Mozilla or in your other projects?
Not so much in parsing because we are in a tight competitive regime with other browsers and you have to parse very efficiently, lex very efficiently. But in building a browser, you end up memoizing or caching a lot. You end up trying to remember decisions you made that were expensive, that can be preserved under some rules and reused. We also have a memory management system that's quite complex. We have a garbage collector for JavaScript. We have a reference counting system for our C++ code. The two have to meet, and it's possible to form cycles, which then have to be collected. We use an old David Bacon dynamic programming trick, Bacon and Rajan, PLDI 2001, I think. It's a cycle collector for reference counted objects. And it buffers pointers that it suspects of forming cycles. And a pointer in a reference counted graph can form a cycle if ever the reference count is going down from above 2 to 1 or above, so that you may still have a stuck reference there due to a circle. And so we use these techniques. We're constrained a little bit in using C++ that has to run on Windows, Mac, and Linux. But in Python and JavaScript, people memoize all the time. And there's a craze now for PEGs, parser expression grammars. I think that's the acronym. I always mix it up with something else, but it's a parsing technique that can use memoization when it's backtracking and ordered choice. So we're familiar with this, and we try to use memoization to good effect. At Mozilla, we have less use in parsing, more at runtime, I'd say.